Hi guys, welcome back to AP Environmental Science. In today's video we are covering topic 6.1 on watersheds and then 6.2 which is on different sources of water and how we kind of use those water sources. So before we get into that, we do have to talk about the different types of water here on Earth, where they're found, and what we use them for. So we should know that the majority of Earth is covered in water. About 2/3, 60 to 70% of Earth is water, and the majority of Earth's water is salt water in the ocean. About 96.5% of all water on Earth is found in the ocean, and it is salt water. The other 2.5% is fresh water, and that includes surface water, so waters that we find on the surface. So that would be lakes, rivers, frost, ice. Then there's also groundwater and glaciers and ice caps. So if we take a look at this first section here, this is our total global water. The majority of it is water found in the ocean. We do have other saline water. Saline means salt. And a very small amount of water on Earth is fresh water. And that is significant because we should know we cannot drink salt water as humans. It is not drinkable by us because of our homeostasis. We can, however, drink fresh water. But this 2.5% of fresh water is now broken down into a few main categories. So of this 2.5% of fresh water, 68% of it, almost 69%, is trapped in glaciers and ice caps, meaning that this is also unusable to us. We cannot use this for drinking purposes, bathing purposes, agricultural purposes. We have to rely on the other types of water, which is groundwater at about 30-ish%, and then other surface water. So this 1.2% is then broken up. So this is then now broken up into smaller categories. So of that 1.2%, 69% of that is ground ice and permafrost, which again, we cannot use. So as you can see, the big chunks of water that we do have on Earth is unusable. We absolutely can take water from lakes. We also can take it from rivers, but this makes up a very small percent. There's more water actually present in the atmosphere than there is in our rivers. So the majority of our drinking water we're getting from the ground, and we're getting from lakes, rivers, and other aquifers. Now, of course, oh wait, no, I don't want to delete the recording. I want to delete this. I want to delete this. Oh my God. Oh, clear all. Okay, here we go. Boom. This entire unit is all about water, both fresh and salt water, and how we are disrupting aquatic ecosystems. Not so much focused on the pollution aspect because we have a whole unit on land and water pollution. This is just more about water systems and how we are disrupting those systems in a non-pollution way. Can I go to the next slide? Yes, okay. So this first topic is all about watersheds, and watersheds are all the land and area that's going to drain into a particular stream, lake, river, wetland. So if we take a look here, this whole area is a watershed, and you can see it's draining or going into a body of water. And there's a few different ways that watersheds are characterized, and that is area, which is basically the size, the length, which is how long it is, the slope, which I'm kind of highlighting over here. This is how steep the water has to travel down, the steepness of the land, and also the vegetation, which is the plant life present in that area. So we should know now that trees have this very stable root system. They're going to anchor the soil to the ground to prevent erosion. And when you have plants in an area like this, hypothetically more water will be going into the soil because it has to be absorbed for the roots. Therefore, less water would run off into a body of water. So this entire topic is all about watersheds. New Jersey is divided into 20 main watershed areas, and they're further grouped into 5 major watershed regions, and here they are here. So we are in watershed number 9. We're in the orange zone, and all of these areas are going to drain into a particular watershed. I live in zone 12, and all of our watersheds here drain into the a few different ones, but one of the main ones is the Manasquan Reservoir. So that is where I am currently living. So, oops, not what I want. Bam. Okay, so these are the few different ways that watersheds are characterized. So one of them is the slope. The steeper the slope, the faster the water is going to flow, more erosion. Imagine you have a slide that is really steep. You're going to travel down it faster than if the slide has not as steep of a slope. And that's not a very good example. What's another? Let's do this. Okay, so this is very steep. It's almost a 45-degree angle, whereas this is less steep. This is going to travel faster, whereas the other one is going to be slower. Now, notice in your notes, if you haven't noticed already, that this note packet is very open-ended because we're moving into the second half of the year, and your notes are going to be a little bit less fill in the blank and more up to a style that fits you the best. So anytime a teacher begins to diagram things on the board or on the slideshow, it's highly recommended that you also write down what they are writing. That's what worked for me in college, and that is what I assume will work for you. So anyway, a steeper slope, the water is going to move faster, and because the water is moving faster, you're going to have more erosion. And again, erosion is just the washing away of soil due to wind, water, weather, stuff like that. Whereas if you have a gentle slope, you're going to have a slower flow and then less erosion. Neither of them are necessarily bad, it's just these are the characteristics of a watershed. The soil type is another big thing. If we remember, we have these 3 particles: sand, silt, and then clay. We should know that clay has the smallest pore, that silt, oh, that's kind of purple, oops. That silt has a medium-sized pore, and then sand has the biggest pore. If you have a bigger pore, more water can be absorbed or drained through it. Whereas if you have a smaller pore, less water will go through. Imagine the size of a drain. Okay. A really big drain hole, more water can go through, and a small hole, less water can go through. So if this soil is primarily clay, you're going to have more runoff. Oops. Runoff. And that's because it's going to have less absorption. And that's because the pore is small. And that makes sense. If you have a shower or a bathtub and the drain is really small, it's going to fill up with more water. So when you have a watershed and the soil is primarily clay, more water is going to run off into that watershed, kind of like what we see here in New Brunswick with the Raritan River. We have primarily clay soil. We have a lot of impermeable surfaces, meaning that they're not absorbing the water, so more of the water is going to run off into a watershed. We also have the vegetation, so this is the root systems. We know that these help keep the soil stable, and they also are going to help absorb water. Less plants means less stable soil, more runoff, and less absorption of water, meaning that more of the water will be running off into a watershed. And again, that's not necessarily bad, it's just how things are. It might be thriving if you have an ecosystem where a lot of the water is running off into a watershed, because there are a ton of aquatic and terrestrial life like beavers and fish and deer that are going to rely on the flow of the water in these watersheds. So just because it has less plants, it might not necessarily be a bad thing, but you guys do need to know what something is and the potential cause and then the potential effect of that thing. So we're kind of using everything that we have learned about so far this year, especially as we enter the second half of the units. Now, down here, a lot of this stuff is coming right from College Board, which is where I'm using all of my resources to help you guys for this test. So the AP Environmental Science exam will often ask you guys to propose ways to improve water quality in a watershed, and we're going to get to this a little bit more when we do our pollution unit. But restoring vegetation or forest cover is an easy solution because it decreases soil erosion into surface waters, thus decreasing the impact on water quality. We're going to practice more solution-based questioning this half of the year as we start to learn more and more about the foundational stuff from the beginning of the year and the cause and effect things that I was just talking about. So we'll get more into practicing solutions later this year. Now, this is something we already talked about, especially when we were going over clear cutting in our last unit, the deforestation method, where we're doing the mass removal of trees, and we were talking about how when you remove a bunch of trees from an area, you're going to have an increased temperature of the water and an increased temperature of the soil, and these are other things that are going to impact that. So we know that when you are clear cutting, you have increased soil erosion because we have less stable root systems anchoring the soil to the ground, more runoff. And again, runoff is just when water is flowing from a starting point to an ending point. And it is a natural thing, but humans are impacting it. When we remove the trees, you're going to have more water running off into another area as opposed to being absorbed into the soil. Now, as water is running off into a river or a stream, it can carry particles of soil. It also can carry pollution, which we'll talk about later. Now, particles of soil is going to result in increased turbidity, which is the cloudiness or the clearness of the water. And this is important because you guys might not be able to see underwater, but you have to remember all life on Earth is adapted to its environment. If we take a look at these two ecosystems, A and B, ecosystem B has a lot of vegetation, it has stable root systems, so when water does run off into here, it's not carrying as many particles of soil, making the water very clear. This allows life to see their see their prey and to find mates. It allows the sunlight to penetrate. That way we have photosynthesis. But over here on this side, we have less vegetation, meaning that there's more runoff, meaning that we have increased sediments and nutrients entering the water. We're going to have reduced visibility, less predation because you can't see your prey, less photosynthesis because sunlight can't penetrate as deep, and we start to see these cascading impacts of cutting down trees, which again might seem simplistic, but once you start getting into the in-depth things, we see these step-by-step causes and impacts to these aquatic ecosystems. So this is something that is super important and comes up a lot on the AP test. This is something, again, that we've already talked about. This is the increased soil temperature and temperature of the water. Trees provide shade from the sunlight. That way, when you do have the sun penetrating, it's hitting the roofs of the trees and not as much as hitting the ground, making the temperatures lower of the soil and of the river. But when you have no trees or less trees, it's going to directly hit the soil and the water, causing higher temperatures because we have no shade, and we have direct sunlight hitting that area. And again, all life on Earth has this ecological tolerance, a range that they can withstand, and when they no longer are within that range, they start to experience stress. So, what can we do to reduce human impacts on watersheds? Making sure we're implementing more sustainable erosion control methods, ensuring that we're keeping our plants there, that they have nice stable root systems. Poison ivy, which, you know, is poison to us. This actually has incredible root systems that help keep the soil nice and stable. And when we go to Sandy Hook, I'm going to tell you guys to be very careful, because some spots of Sandy Hook, I don't think exactly where we're going, but some spots they absolutely have it. They purposely planted poison ivy along the coast to prevent coastal erosion, which again, we will talk about later in the year. But when you plant these plant systems that have these stable roots, we're going to prevent erosion, especially coastal erosion. We want to reduce the impervious surfaces. We want to make sure that the water is penetrating into the ground. And we also want to have policy and regulation on limiting what pollutants we're putting into the environment to prevent them from running off into a local waterway. Okay, so this is now more about other ways we're disrupting water systems that aren't specifically watersheds. So this is talking about floodplains, and floodplains are exactly what they sound like. It's an area that can potentially flood, and floods might sound really bad, but there are a lot of positives to areas flooding. So before humans intervened with this, some riverbanks would flood or overflow, and this would result in very fertile land, meaning it's high in nutrients, it has perfect salt concentrations, and crops would thrive here. And in this area here, which I hope is familiar to you because you all took world history, this is the Fertile Crescent or Mesopotamia. This is the dawn of civilization. If you see here, we have two main rivers, the Tigris and the Euphrates River. This was an ancient floodplain that would flood, and this is where the dawn of agriculture and the dawn of civilization began 10,000 years ago. So Mesopotamia really was where modern civilization, you know, to an extent, was born. They relied on this floodplain to flood and thus produce very fertile soil. However, now that we have become so overpopulated, we do not want areas that flood to flood. And we can see why, especially when we look at what happens here in New Brunswick. So one way to prevent flooding is to construct something called a levee, which is an enlarged bank built up on each side of a river. And the consequences of this is it reduces the fertility of surrounding land because you don't have it flooding with nutrients. The sediments are carried further downstream. Therefore, we're increasing the turbidity, which is the cloudiness at the ending spot. We're preventing flooding at one spot, but it's going to result in flooding somewhere else. And this encourages development in floodplains, which will eventually flood anyway, causing more impervious surfaces. I don't know why this didn't finish, meaning which brings more runoff and less water being recharged into a groundwater or an aquifer. And this is a very common example. So this is, where's my little pen? This right here is the levee, and you guys have driven by this all the time. This isn't in New Brunswick, but they have these here in New Brunswick. It's essentially just a big wall to prevent the water from going over when it floods. But if there's enough water or a big enough of a storm system, it can potentially flood anyway. So normally, if this wasn't here, all of the water could flood this area, but we don't want that because we want to build, because we want people in our capitalistic society. That's just what we want. Now, unfortunately, when you have a buildup of too much water, it can cause the levee to collapse, and the most famous example of this was Hurricane Katrina. So it's a common misconception that the actual hurricane was causing the fatalities. That's true to an extent, but what essentially happened was the water built up so much that it caused the levees to collapse, resulting in massive and catastrophic flooding. So this is what ended up causing the majority of the fatalities and $80 billion in cost damages, not the actual hurricane. A dam, this should be familiar. A dam is a barrier that runs across a river or a stream to control the flow of water. Water will still flow through it, it's just not as fast or as rapid. And the body of water created by damming a river or stream is called a reservoir. So dams hold water for a variety of purposes. One of them is for human consumption of that water source, the generation of electricity. A lot of people think that the majority of dams are for this purpose, but only 3% of dams worldwide are actually for generating electricity. The primary reason is for flood control. We also can then prevent the flooding so we can have housing, and it's also kind of scenic, I guess. Dams have been around for centuries, with about 800,000 dams worldwide and 84,000 in the US. Do you have to know those numbers? No. But dams are a very common way to prevent flooding. And this is the Three Gorges Dam in China. This is the biggest dam in the entire world. It's 1.3 miles long, and this is a huge topic on the AP exam. I promise you this will come up in some capacity. There is some geography on that test. So you do need to know that the Three Gorges Dam is in China, and it has a lot of benefits. It does include a large amount of hydroelectric power, which is a renewable resource. We'll get to that in our next unit. And it also has prevent flooding. So today, nearly 2/3 of the world's rivers are no longer free flowing because of these dams. And this is a problem because no free-flowing rivers can result in a lot of consequences, and one of the biggest and most common ones is it prevents the migration of certain fish species, including salmon. So salmon will actually return to their freshwater river to lay their eggs so they can spawn more offspring, meaning that's how they make their population go up. If you have a dam blocking their path, you have a decreased salmon population. And we know that humans are already impacting global fish species through overfishing. So now when we're building these dams, we are now preventing the salmon from going back to their ancestral spawning grounds, thus reducing their population. They trap sediment, increasing turbidity. They change the water flow, resulting in changes in temperatures and chemistry. It's going to kill the fish because it's passing through the turbines, which kills millions of fish each year. And this is actually such a problem that what they had to do was they had to modify these dams to incorporate something called a fish ladder. So this is something you all need to write down because it's a solution to the impact of dams. It's a fish ladder or a fish staircase where the fish will hop into each section. That way they can travel through the dam to get to their ancestral spawning grounds. And it looks something like this. Now, this is something called a wetland. A wetland is an area with soil submerged or saturated in water for at least part of the year, but shallow enough for emergent plants. And New Jersey actually is filled with wetlands, and they are one of the most productive terrestrial / aquatic habitats on Earth. And they're actually so important that when you want to build in New Jersey, you can't. Because you can build in New Jersey, but you have to write this thing called an environmental impact statement that will discuss how you're going to impact the environment. And if you're going to build over a wetland, you have to build a wetland somewhere else to the best of your ability, because they are so important just for so many different reasons, and these are some of them. Remember those ecosystem services we talked about in our previous unit? Those come back around. Provisioning services are things that we can divide up and trade. Plant foods. Regulating is groundwater recharge, absorption of flood water, carbon dioxide sequestration. This is the absorption of water. Supporting is water filtration, pollinator habitats, nutrient cycling, and cultural is like the educational, aesthetics, the beauty. So tourism revenue, people go here for fishing, for camping, and also a lot of these plants are used in medicine. Now, these are something called mangroves. They are these incredibly beautiful semi-aquatic, semi-terrestrial plant species that grow in salt-tolerant waters, meaning that this water is salty, meaning that this is primarily along the coast because it's near the ocean. And as you can see, look at these root systems. They are massive, they are crazy, they are humongous, meaning that they are going to prevent erosion. They provide these buffers or areas to help against storms, coastal erosions. They stabilize shorelines, they filter pollutants. They also act as nurseries or estuaries for marine life, meaning that this is where marine life will come and lay their eggs rather than laying them in the open ocean, including fish, crabs, and shrimp. And they also sequester massive amounts of carbon. So these things are so incredibly important and beautiful, and unfortunately, we are disrupting them. So ecosystem services of mangroves, you don't have to know all of them. These are some of the few. Pick a few that you'd like to write down. But these are the ways. Oh wait, where'd it go? Oh no, is it not here? Hold on. Aha. Sorry. I don't know why my slide got all messed up. Insert animation. Okay, let's see if that fixes it. Guys, as I'm becoming old, I'm becoming tech illiterate. Order. Bring the front. Okay. These are some of the threats. So, logging, which again, deforestation. This causes habitat fragmentation. We're going to have increased erosion. We're going to lose our aquaculture, these are being removed so we can plant aquaculture farms, which we'll talk about in a little bit. They're being removed so we can have agricultural farms like rice paddies. Coastal development is the big one. We want to remove these. That way we can build coastal cities. So these are such incredibly important areas that we are destroying, unfortunately. Now, what you guys need to do is, when you finish this, you guys need to do the Watersheds Practice FRQ using primarily the information from topic 6.1. And if you have any questions about this stuff, please come check in with me or go over with me. I am going to link a few videos and resources that you could refer to if you need it, because again, a lot of this stuff is new, you've never learned it before, or we're taking things that we've discussed previously and applying them to a new context, and you might need some more support with that. So make sure you guys finish the 6.1 Watersheds FRQ. That is due next class, and this unit is really quick, so stay on top of your work, and if you need anything, you know where to find me. Have a good day.